Good morning, everyone. Welcome to Idea Statica webinar. We had some technical issues, so I hope everyone can see my screen now. Welcome to another Connection Wednesdays, and today we will have a look at a way how we can collaborate with our colleagues on one more complex structure. My name is Jana Kadirova, and I'm here with my colleague Adam Kozoušek. Hello, Adam.
Let's unmute myself. Hello, welcome to everybody, ladies and gentlemen. Welcome to all fans of fancy structural engineering stuff. That's enough.
Perfect. So we are both product engineers at Idea Statica, and we will lead you through today's content. Before we actually start, let me mention that you can give your questions via the questions panel in GoToWebinar. We can see them here, so we will try to answer all of them during the webinar. If there are more than we are able to manage, then we will send you a reply after the webinar. So today's project, it's a project of connection design of this steel hall. The steel hall is modeled in SIA Engineer, and Adam will be responsible for design of steel connections. And we will have, let's say, two different roles in this project. So he will be we call it junior engineer, somebody who just started and needs some advices from, let's say, senior engineer, and we will show you how they can cooperate in quite an easy way. So you will see how to design this more complex connection step by step. And of course, we will show you the export project via our Idea Statica checkbot, and also how you can speed up your design process and how you can share your designs with your colleagues via our connection browser tool, which is quite new. So that's all for the beginning, and to warm up, we have prepared the first poll for you. So the question is, I will launch it. And the question is, I use the BIM link between my finite element software for the global analysis and Idea Statica. So is it on a regular basis, or let's say quite often? Not really very often. I tend not to use it, or not at all. Please let us know so that we have a picture of our audience. How are you familiar with our tools for BIM link? I will give you 10 more seconds so everybody can vote, and I will close the poll now and share you the results. So you can see that it's quite the distribution is quite equal, and thank you very much for this. So we can see that there's a big potential. You can learn something today. And now I will pass the presenter to Adam, who starts with today's content.
All right. Thank you, Anna. I'll take the presenter. You should be observing now SIA Engineer, one of the global structural analysis software that we are linked to via our BIM links from Idea Statica software package. And guess what? I got the role of the junior engineer, or let's say a recent graduate. And let's say one of my first jobs was this steel administrative building that I had to design, analyze, and check. So I've done this using the software. Everything is all right. I have designed and checked all the members of this structure. All is fine. And now my second task on this project is to design and check the connections. So since I have Idea Statica on my computer, I will take advantage of that and use the BIM link, which is hiding in this software under this command. So let's launch it. What happens is that the checkbot application opens. A checkbot application is the, let's say, manager for importing and operating connections via BIM links. So what I have to do is here, as the first step, choose either steel or concrete project. Obviously it's a steel one, and I can choose the code under which I'm going to perform the code checks. So let's stick to Eurocode in this case. And this is the UI of the checkbot, and I can start right away. What I do is that I select any node and corresponding members in this project, and I will start with something simple. So let's use this anchoring of this column. Click connections. Now those data from the global structural are imported into checkbot. They are here. I can take a look at the model in the 3D window. I can see which members are connected to this and so on. I can do whatever I like, show internal forces and so on. I can do many things here, but I'm not going to go to details in those, and I will open this connection for the design right away. So click open either here or here on the ribbon, or via right click in the list. And this is something we are, most of us, let's say, familiar with, Idea Statica connection. So now my task is to design the anchoring. I can use operations and things like that, or I can use another great tool of latest versions of Idea Statica Connection, and that is Connection Browser, which is laying just here in the ribbon. And I will use the Propose button, and that basically proposes me or gives me or advises me with possible designs for given geometry or topology of what I have in the node. So here I can choose from some predefined templates. In this case, it's just a simple project and simple anchoring. So let's go for a simple one here. I'll change the anchor grade and choose the size M16. Leave the default concrete material is 25 by 30. All right, there we go. Can do slight change, just have a thinner base plate. And what I can do is calculate right away. In this case, I will not calculate all the load combinations that are all imported from the global structure analysis software, but just one to save a bit time during this presentation. So I can see all code checks are green, all is all right. I'm satisfied with this design. And with the results, I can just save it, close it, and I can see in the list there is the green mark next to that node, and also I can see the overall results in the picture of the design in here, and I can continue. So this way I can cover most of the simple connections. You can see it's pretty fast. The biggest advantage is that you don't have to do anything about the geometry cross sections, and you have all the important load combinations imported, and you can calculate them at once. All right, so that's a great tool how to be efficient. Now I will try something more difficult. Let's say this node. I have a wind bracing diagonal here as well, so let's import this one. And now, as I get back to my role of junior structure engineer, I am not that skilled or experienced with designing, let's say, moderate or slightly complex connections. So if I open this, you can see the column and the main beam. We have here SHS members connecting to this and the diagonal. And now I'm afraid I'm not really sure what to do. So what I will do is call to my senior professional structure engineer colleague Jana and ask her for help. She's sitting in the next floor, and I will share the data with her and ask her to help me with the design and share the template or the design with me within the connection browser. So I can take advantage of the checkbot feature and save this one node or connection into a single file. Let's call it N239, and let's put it on my desktop. Okay. I can show you my desktop. There is the file. And now I can send the file to Jana by Teams, email, or whatever, burn it on a CD. And I will call her and ask her for help. So, Jana, are you ready?
Yes.
To help me? Are you ready
Okay.
to teach me a lesson?
I will take the presenter and start working on that project. Okay. So this is the file Adam has just sent me, and let's open it. I have it here. So you can see there's, of course, there are the members from the global model, and there are the loads. I will just hide it to have more space here and start the design. So I can go one by one with our operations, or I can just employ our connection browser to help me a little bit. So I can either open it from the top ribbon, or I can also open it by using the right mouse click. So let's say I want to connect this horizontal beam to the column. I will click on it with mouse. Okay, no, it got stuck somehow. Okay, sorry for that. So with the right mouse click, you can use this connect to and select the column. And now the browser opened, we can see the library of suitable designs for this configuration for these two beams. So let's say I want to use this design with the stiffener. Press OK, select the bolts. I will leave the default option here, and I have some initial design that I can now adjust. So for the first stiffener, I will leave it as it is, and I will adjust a little bit the end plate. So first, let's make it a little bit shorter because I want to put the bottom bolts inside. I want to add another row of the top bolts, and for the bottom bolts, I want to put 2 layers, but a little bit more up. Okay, and I want to make the widener first thinner, but I will change size of it to 200 millimeters of width and 250 in depth. You can see that whenever I change the parameter here in the table, it immediately changes in the scene. So you have perfect visual check of the design. The second stiffener is this one. I will again leave it as it is. And the third stiffener, I will just relate it to the end of the widener. So I can do it by selecting this related to. Let's select the widener, and I have also changed the X position, and I want only one because now you can see there are 2 of them. I will use only the lower one. Perfect. Now when I move the widener, the stiffener also moves together. The last operation added was the cut, which is the cut of the column based on the farther flange of the horizontal beam with 20 millimeters offset. I will change it to 10 millimeters. Perfect. I have designed the connection of the horizontal beam. Now let's focus on these 2 perpendicular closed sections. I will connect them using a stub. This time I will select it from our library of operations. It's here, stub, plate to plate. So let's add it to the list. Now I have to correctly select the connected member. I can always choose it in the drop-down menu here, or maybe more easier way is to use this pick by mouse. So let's select this member. You can see the operation appeared, and I need to change it a little bit. I will make it thinner, and I will select. I will change the dimensions of the plate to plate, 40 and 10 millimeters in size. And now the bolts are inside. You can see it here. So let's put it outside, 20 and minus 25, like this. Perfect. Maybe last thing, I have to switch the weld to be from outside only. I want to add the same step at the opposite beam as well. I can do it easily by copying the last operation. Again, right mouse click and copy. And the only thing I have to change is to select the opposite beam, and it appeared. Perfect. The next step will be to weld the stub to the column, but because it's not welded at the moment, you can check it always. If you cannot see it in the solid view, you can always check it in the transparent view. If I zoom it, you can see this is the edge, and there is no yellow line. The yellow line represents the weld. So if you need to check sometimes whether the weld is correctly created, I advise you to switch to transparent view, and you can directly see the yellow line. So let's add it there. The easiest way to weld it is to cut it and weld at the same time. So this time we will cut the stub. Let's use the pick tool, and it will be cut by, let's select the column. Perfect. And now you can see that the yellow line appeared. If I switch to solid view, you can see also the weld, but again, let's weld it only from outside. And the same will be applied at the opposite side. So again, copy and switch step 1 to step 2, and the weld is there as well. The last not connected member is the diagonal. For that, I will use the connecting plate from our library. Again, first I will select that B268 should be connected, and I want the gusset plate to be related to the step and also to the beam. So for that, I will change it here. I will change related to step 1 and also the beams, the columns. So you have to switch here the cross to member, and let's say you can use it, the picking tool. Perfect. You can see that it was immediately welded. Now I will change the size of it to 30 and 150. I want to shift the connection a little bit farther, like this. And also I will change the size of the connecting plate itself, like this. The cap plate should be circular, not rectangle. And I want to have 20 millimeters offset, like this. Perfect. For now, I will also add another bolt there. So there will be 2 bolts, 30 millimeters, and this will be 50. Yeah, like this. Perfect. Let's say we are finished with the design, but also we have to solve 2 last things. The first one is this clash. You can see it in the transparent view. So the shape of the plate can be changed in editor. Editor can be opened either here in the top ribbon above the table. You can see there are 3 different plates: the tongue, the gusset, and lid. I want to cut the gusset and add there bevel. The size will be 80 to 50, and the corner will be corner number 2. If I apply it, you can directly see that the shape changed, which is what I wanted. I will confirm. And if I take a look at the connecting plate, maybe we would like to have it the corners to be rounded a little bit. So let's open the editor again. This time I will again use my mouse and right click and open the editor from here, which is even faster. And for the connecting plate, you can see also there are 2 bolts. This is the place where you can manually shift the bolts if you want some uneven distribution of bolts, let's say something which is not symmetrical. So you can achieve the precise position by exploding this table and shifting it here. But this is not what I want. I want to add rounding. The rounding will be 30 millimeters, and there will be 2 corners rounded like this. Okay, and it's here. So now I'm almost ready to start the calculation. There is just one thing important to mention, and this is the connection of the diagonal, because this should work as a hinge, and for a hinge connection, the model type must be changed. You can do it again in a tree. If you select the corresponding member, the diagonal here, we will switch the model type to NVY-VZ only. This is because we want the diagonal not to transfer the bending moment. If I leave the model type as it was, the default one, then the model will have big convergency problems, or will not, the calculation will not run at all, because the moment will be applied there, and these two bolts will not be able to bear it. So we are ready to calculate. You can see there are plenty of combinations imported, therefore it would take a lot of time. Therefore, I will change the selection only to the first one, which I know is the most critical one. And for this demo, I will calculate only the first one. So now the model is being meshed, and the load is applied in steps. And in a while, we will see results. We will see what we call the traffic light view, with the main colors representing on what level of the capacity we are for the particular component. So you can see a lot of green, meaning that these plates are somewhere between 60 to 95% of their utilization. The orange means 95 to 100. Of course, if it's above the limit, if it's above 100% of its capacity, then the color would change to red, and you would also see red cross here. But for now, we can see that the design is quite fine, and I can send it back to Adam to use it in his steel hole design. Now I don't have to send him email or CD or whatever. I can save the design to our company design set. So Connection Browser has the second button, which is called Publish. I will open it, leave the name as it is, and here I can select between my private set of designs and company set. My private, it's clear, it's only for me, nobody else can see it. Company design set is the one that is shared with my colleagues. So if we have the same company license, anybody can save the design or load the design from the company set. The only thing I need to do is I have to be online at the moment I'm publishing it. So you can see publishing process was successful. I'm finished, and I can call Adam that he should now be able to find this template in our company library. So Adam, are you here?
Yes, I have just finished my coffee and sandwich.
Perfect. So you can continue refreshed working on your project.
All right, so taking back the presenter, and we're back in my office of the junior engineer, and I'm just finished call with Jana and thanked her gratefully for helping me with design of this complex joint. And she just told me, she dropped me the template of such joint and similar joints that I should use within this project. So I open this once again from my browser, go to Propose. Here I find the design template he just published 2 minutes ago, and I just click OK to apply it here. I can choose different set of bolts, but I will stick to the same one, of course. And there I go. My job is done. Again, what I will do, I can calculate now and code check all the load combinations imported from the FIA software or the structural software, but I will save time of yours and calculate just one and code check it. So let's see how this ends. By the way, I like the design very much, and by observing this, by learning from what Diana prepared for me, I made another step in my bright career of a structural engineer. And there I go, another one finished. That was pretty easy. And now I can continue. I know how to do very efficiently all the simple connections with help of checkbot and browser. With help of Yana, I can cover also the complex ones. So let's see, for example, about this one, right? This is probably the most complex node in this project. So let's import it. And let's see if I am able to do it now with all the tools and knowledge I have now. So I will select this one and open it. And let's see. Here, obviously, I don't have any design in the propose function of the browser, no template for this. But if you remember how the other connection looked like, it was pretty similar, just there was not the upper diagonal and the upper part of the column. So let's try a function of browser, and that is that I can select just a part of the connection. Do it like this, click on that arrow symbol, drag and drop the mouse, and confirm the selection with the space bar or clicking on this icon. And there we go. For this one, has the same design as the previous connection. I can use this template. So let's apply it. Again, same bolt assembly. And I have designed most of this complex connection. What is remaining is the diagonal and the column. So for the column, I will use another way of approaching the connection browser, and that's the right click. Here I can select from the menu Connect to and select the other part of the column. And again, possible designs for this connection appear. And this time I will go for an end plate. Again, same bolt. And there it is. I'll just slightly modify it. Thinner end plates. There is this offset, which should be 0. And I will also move this connection upwards to hide it in the floor of that building. And what's else? I will delete these bolts here and change the weld position to inside only for the flanges. There I go. That was pretty easy, even for a junior engineer. And now for the diagonal, let's just copy the same one as it's for the lower one. Why not? Okay, so I select the tube here, and there I am. I have a clash here with the stiffener. If I see the transparent view goes through, I can easily assess this with the cut-off plate operation, and I will create a notch in the connecting plate. So I will select connecting plate, here switch to plates and select the stiffener. Now the connecting plate is cut like this, which is not nice, but by switching to notch here, I am ready with the design. You can see the notch in the connecting plate and the welds around it. All right, so I'm good to go. The last thing is that I also changed the model type, as Diana did, to the wind bracing type and VV. I do this for the lower one as well. And I can calculate again all or just one load combination. You can see for this connection there are more because there are more possibly dangerous load combinations that went through the filter in the checkbot. And I'll try to calculate it. And whoops, there is some error or message that bolts are too close to plate edge. Operation EP1. So let's see what's going on. I will select the EP1. That's the end plate here, and take a look what's wrong. All right, so I can see now that those bolts are really almost out of the column flange. Why is that? Is there anything wrong? Well, I can identify this easily if I go back to the checkbots, or as the author of this structure design, I know it. There are different cross sections or profiles for these two beams. So for the original design, there is HEA200, but for the current nodes, there is HEA240, so bigger cross section for the connection that I'm designing on calculating right now. That's why those bolts don't fit here, while the end plate adjusted to the size of the connected member, which is the bigger. All right, nothing serious. I can just move the bolts on both sides a bit to the inside, and there I go. All right, I'll calculate it right away. And see if I pass the code checks and everything is all right. Let's wait for the finite element analysis. All right, so this connection is okay as well. I am fine with the design, so I just save it, close it. Again, I can see the green mark here that this connection is completed and successfully code checked. And that's it. That's all I wanted to show you from my perspective. I've designed 3 connections. I used Checkbot and Connection Browser to speed up my work. And I will now pass presenter back to Jana. She has prepared another poll for you, right?
Exactly. So thanks, Adam. And now I have a poll for you, second and the last one. So let's launch it. And this time I would like to know, how do you design some repetitive, simple connections, such as easy end plates, fin plates, and so on. Do you use Ideastatica connection for the simple connections as well, or do you prefer to do it manually with some tables, or a lot of people have some Excel sheets for each operation, or you don't do it at all? So please let us know. I will give you 10 more seconds to vote. I can see the results now, but so let's close voting, and I will also show the results to you. So you can see that there are two significant groups. Most of the people use Ideastatica connection, which is perfect. We are really happy to see such a result. And there is also a big group of people using Excel sheets, which is very standard way of doing it, but a little bit old-fashioned, and maybe it can change in the future and switch to some sophisticated tool. Perfect. Thank you very much. And now it's time to see some or answer some questions. So there was a question about the connection browser. If you save a template, you are able to apply it also in case if there are other cross sections, which Adam, I think, presented. But Adam, can you just sum it up, please?
Yes. Well, okay. Let's share my screen again and open the connection again. So a browser and the propose function, as is here. If I understood the question correctly, the geometry that you have to use the design template for, it doesn't have to be exactly the same. As you saw, for example, this beam was HEA 200 for the original template in the browser, and I used it for HEA 240. So there are tolerances. The cross sections or profiles, they don't have to be the same. So that's great because you don't have to create templates for each slightly different nodes or connections. So one thing is cross sections don't have to be the same. Other thing is that there are also tolerances in the angle or vectors of the members. So if this member was, let's say, tilted by 5 degrees, I could also use the template. Yeah, I hope that's clear. So the geometry doesn't have to be exactly the same, but there are some slight tolerances.
Yeah. Okay. Perfect. Good. Thank you. I have another question for you. When forces changes in model, is there some automatic change in idea connection? There are more questions like this. Or is it possible to update any loads from the BIM when the connection is already designed?
All right. That is possible. Let me show you. So if I have, for example, this imported in Checkbot or even more of connections, and in the original model, I change maybe some cross sections because I got some, I don't know, needed changes that I had to do from, I don't know, architect or project manager or whoever. And then also, so the cross sections change, and also the values of internal forces after calculations change, I can simply synchronize all of them by clicking on this sync one item, so one connection, or all items, so all the connections. So that updates the cross sections changes and load values changes. Yeah. So this is an easy way how to keep your connections up to date, and at the same time it doesn't delete any design or whatever the job you have done. The only thing is that is important to say, if you add a completely new load combination in the structural model, this will not come to a checkbot with the synchronize. It only updates what you have created, but doesn't add new items. If you do this, you need to delete the connection item and import it again to get more load combinations added later. Yeah.
Okay, perfect. Adam, can you also show us the loads from the top ribbon? Because there was a question, how can we influence the loads that is imported?
Yes. So this is sitting here. If I click on this, this is the manager of the loads. So imported items, these are the load cases and load combinations that are imported from the structure model. That's all of them. And these go into my connection design and calculations. So by default, there is a filter that it takes in combinations and usually neglects the load cases because load cases are inside the combinations. So it wouldn't make sense to calculate them while we have more dangerous load combinations here. Also, there is an advanced filter that then for each connection decides which of those combinations are dangerous or relevant and which are not relevant or are like duplicated, so they don't have to be calculated.
Perfect.
This filter you can turn on off here, and you can of course delete and create your own group like this. And if you like, you can of course calculate just these two load cases for your connections. So it works like this.
Okay, I have another one in Checkbot. Is it possible to merge two members together?
Yes, that is also possible. For example, for this column, if I would like to have this as continuous, which is not in the global model, but it could be, but I can decide to merge it in the checkbot later on, and I can do it like this. Click on merge. Yeah, there is an open connection, so I'll close it. And now it shows me a possible merging or possible members to be merged. So I click on the upper one, click merge. This tells me that this node will be reset because of course I'm doing a big change, and now I have the column as continuous.
Okay, thank you very much. Now I will answer some of your questions. What BIM links work in expert version? So in Ideastatica Expert, you can use all the BIM links to our finite to your finite element solutions for the calculating tools that you use. The CAD applications as Tekla, Advanced Steel, or Revit are included in the enhanced version of the software. Maybe let me share back my screen. I will take the presenter.
I would
Okay.
just add to this that what you have seen here, you can do with the expert.
Yeah, exactly. So, and if you are not sure about what version of your application is supported, or if your application is supported at all, you can go to our web page. In the top menu, you can see BIM and supported integrations. There's a list of applications that are linked to Idea Statica. For example, I can select SAP 2000 and I can see the table of compatible version. The rule is that we always support the last two major releases. So for SAP 2000, it's 23 and 24. There was one question about RFEM version 6. Unfortunately, this is still in development because we are waiting for Global to change their API so we can read it. So it's a little bit longer than usual because usually we are able to link new version within 2 months. This time it takes longer, but we are sorry for that, but this is a little bit out of our possibilities. We have to wait for them. Okay, there was one question, interesting one. If the member type VYVZ can be used for pinned connections too, or only for bracing? Well, I would say that for the pinned connections, it must be used. So whenever you have a connection with one bolt, you always have to change the model type. You will see that the model would not even start to calculate, or after you calculate it, and you display the deformations and stress and strain, you would see that it totally broke. So you have to use it every time it's, let's say, pure hinge. For cases somewhere between, if you are not sure if it's more pinned connection or more stiff connection, then it's a little bit more tricky. You can always run our stiffness analysis and decide. But what we always say is that the Idea Statica model should comply with your global analysis model, which means if you model a hinge in SIA Engineer, that it will be a hinge, or it should be a hinge in Idea Statica tool, and the internal forces, of course, should comply with that as well. And speaking of pins, there was another question about it. If we can model a pin instead of bolt, this is this question is very often asked. So at the moment, we support the bolts only, and whenever you want to model a pin, you have to use a bolt, and for the pin itself, you need to make some additional calculations out of Idea Statica. The connecting plates are checked correctly, but for the pin itself, some additional, for example, the bending check must be done out of Idea. But I can tell you that this is something we are working on for the future versions, and so it will improve much I'm not promising it will be the next version, but it's already being developed. So good news for everybody who wants to design pin. Okay, thank you very much. There are more and more questions. We will try to write you an email. There were some specific questions about models from Tekla that it doesn't work. So please, if you have specific problems with your project, you can always go to your portal in our web. I will show you where it is. You can see a person pictogram here. It's a user portal. When you sign in, you are able to submit a case which goes to our help desk. So please, for your specific problems, use this, and we will definitely have a look at it. Thank you very much for your time today, and let me invite you for the next webinar, which is held on the June 22nd. This time it will be Connection Wednesdays with Idea Statica Automated. Very interesting topic for all the geeks who want to optimize and use even more advanced tools to design in an automated way. And then we have a summer break, and the next Connection Wednesdays will be in September 14. So please make a note into your calendars and check your mailboxes for our invitations. After the webinar, there will be a very short survey, which we ask you to fill to give us some feedback, to give us some ideas on topics you want to see in webinars. Of course, the recording of today's session will be available in our support center or in our YouTube channel. If you want to try Idea Statica, you are welcome to download a 14-day trial version, which is for free. So please go to our webpage, and there's a big red button in the corner, and all the documentation, if you are interested in some details, please go through our support center. There is plenty of stuff like tutorials, videos, and so on. Again, thank you very much for your time, and have a nice day. Bye bye.
Have a nice one. Bye bye. See you later.